name is Basil. I'll be giving a brief introduction about this project. This is mainly our project. It's an obstacle avoiding car. In the process of this project, we used the Altera, so the language was very long. We utilized a lot of components such as sensors, motors, and H-bridge. This will be further explained into details with my colleagues. A simple explanation of the project: it avoids the obstacles. If it found an obstacle on the left, it goes right and further on. A real-life application for this project is a mouse hoover.
My name is Hisham Meher, and I'm going to explain one of the components that we use in this project, which is the H-bridge. Basically, we connect the power to the H-bridge, and the H-bridge is the one controlling the outputs to the motor, depending on the input that we send to it from our program. Here's where we connect the battery, and these are the outputs for both motors. The H-bridge has 6 inputs: enable A and enable B. Each enables the motor A and motor B respectively. And we have inputs 1, 2, 3, and 4. Inputs 1 and 2, they control the direction of rotation of motor 1. If 1 and 0 rotates the motor clockwise, and 0, 1 rotates it anti-clockwise, and so on for motor B, using the inputs 3 and 4. Basically, this helps us control the direction of the car, depending on the input we get from the sensors as it sees the obstacles, and it helps us in moving the car as we please throughout the maze without colliding with any obstacle.
My name is Amr Kag, and I'm going to explain to you one of our components, which is the infrared proximity sensor. Over here we have 3 of them, one on the left, front, and the right. They always send continuous signals whenever they are connected to the source, which in our project is the Altera board. Whenever they receive an echo from any direction, left, front, or right, an action is done accordingly, and we'll see in the demo what happens.
My name is Loay Hamad, and I'll explain to you how the system functions. First of all, there is an enable button. When it's pushed, the car will go forward until the right signal is cut. Then we will have a slight left, which will stop this wheel and will continue rotating this wheel. Okay. When these 2 sensors are cut, we will have a hard left, which will stop this wheel and turn it into the other direction, and will turn this wheel like this. Okay. And accordingly with the left sensor and the front sensor. But when the 3 sensors are cut, then the car will have a hard right to right. We will continue now with how the motor functions. First, there is an H-bridge. This H-bridge takes 6 inputs from the Altera FPGA. These 2 inputs enable the motor to function, and these 2 are for the rotation of the right wheel, and the other 2 are for the left one.
My name is Mohammed Bahiri, and I'm going to talk to you about some of the difficulties we faced during this project. First, we use infrared sensors, which basically detect objects that are aligned with the sensor only. That means it only detects objects that are on the same straight line, and the other spots are blind spots to this sensor. So we had to use more 3 sensors to cover more area in the same direction. We could have used ultrasonic sensors, but it would have been difficult for us to code on very low. Also, one of the difficulty we faced is that the Altera is relatively big to our car, so we couldn't install it on the car, and so we have to move the Altera while moving the car. Also, the wires are really short, so we have to keep the Altera at a very short distance to the car while moving.
My name is Hatem Said, and I will talk to you about the results of that project. We used the 3 sensors, motors that connected to the wheels, H-bridge, and the Altera as a control unit of our project. As to connect what my colleague said, As the sensor sends signals to the Altera, and the Altera send back signals to the H bridge, which redirect this signal to the wheels, to the motors to take an action, as what Luay said. The H bridge works at what Hisham said. Finally, as Beheri said about what difficulties we faced. After optimizations of these difficulties, we reach this final design. As a result of this optimization, we will be able to test this car in a track, and it avoids all the obstacles there. And we will introduce you now to a demo of that project.